All right, if the answer to this question is yes, we can use them again. Then let's look at this. For this first trial, how many letters do we have to choose from? Well, there are 8 letters, right? I can put any of 8 letters in here. For my second trial, selecting the second one, since I can reuse it, then don't I still have 8 letters to choose from? And for my third trial, well, I still got 8 to choose from because I can reuse them. So all of them are available for use. So there are a total of 8 times 8 times 8 different possible arrangements of the letters, of 8 letters listed up there. And I think 8 times 8 times 8 is, we'll use our calculator and we'll see what it says. 8 times 8 times 8 is 512. There are 512 different ways I can select 3 of these 8 letters. All right, let's continue. If the answer to this question is no, once I use a letter, I'm not allowed to use it again, then we must come to question number 2. And question number 2 says, okay, then once I've made my selection of my 3 letters, can I count other arrangements of these same 3 objects, these same 3 letters? That is order important? By just changing the order of the 3 that I've picked, does that constitute a new arrangement? And again, at this point, when I do this in class, I have several students say yes, and I have a number of students that say no. And once again, I stop in the class and say, you don't get to decide. This, once again, this question also has to be either inherent in the problem itself, or it has to be given by the person presenting the problem. We simply have to go with whatever the answer is to this in determining how many arrangements there are. So again, let's make sure you understand what I'm talking about. Let's do a couple examples. So let's say from my 8 letters of love math, let's say I happen to choose L and E and H. L-E-H, okay? Well, there's one arrangement of those letters, and my question is, the question this is asking here, if I rearrange these as L or E-L-H, are we allowed to count this one too, or not? And if we are allowed to count this one, then that means I'm also allowed to count this arrangement, and I'm also allowed to count this arrangement, and there are several more arrangements I could come up with that I would have to count. If the answer to this is yes, the order is important, and so rearranging the order does constitute another arrangement, then if the answer is yes, then this is what is known as a permutation. A permutation is a rearrangement of the letters, and we count all those different rearrangements. All right. So how do we actually do a permutation? Well, once again, I have my 3 trials. And we're going to fill in how many possible outcomes there are for each trial. It is that straightforward. Okay, if I have 8 letters, then this first letter can be 8. There are 8 possible letters to choose from. However, we have decided earlier that I'm not allowed to reuse a letter once I have chosen it. So now that I've picked a particular letter to be in here, how many letters do I have left to choose from? Well, there's 7 left to choose from. And once I've selected my second letter, and I'm not allowed to reuse that, then there are only 6 letters left to choose from now. And so the answer to calculating the number of permutations that are possible is not 8 times 8 times 8, but 8 times 7 times 6. And my calculator says that's 8 times 7 times 6. That is equal to 336. Okay? Now, because permutations are so important, there is a special function on our calculator that allows us to go straight to the answer. So let me just take a second and show you that. The function is called NPR. Let me show you what that is on the calculator. Let me move this up into here so we can see things a little better. Hopefully you can read this now. All right, turn it on. I guess it's on. We have a key up here in the upper left-hand corner called the PRB key. That, as you might guess, stands for probability. And under this key we have several special functions. The first one is the NPR. The P in here stands for permutations. All right? If I have 8 letters to choose from, and I want to count all the possible permutations from 3, here's what we do. Let's start over. Let's clear this. I have 8 to choose from, so I enter an 8. I press the PRB key, and notice that the NPR function is underscored. That means that is selected right now. So all I have to do is enter how many I'm choosing of those 8. Since we're choosing 3, I press 3, and notice the screen changes, and it says 8 NPR 3. So when I press equals, that tells me that there are, hopefully you can read that, there are 336 different permutations of 3 letters if we have 8 to choose from. Pretty simple, huh? So I don't care if you use your calculator to find this answer, or if you just understand what's going on, not that page, if you just understand what's going on from doing 8 times 7 times 6. That's a permutation. Okay, we've got one more to do here. What if the answer to this second question is no, that once I've chosen 3 letters, I'm not allowed to count the different arrangements of just those 3 letters. Once I've chosen, made my selection, that's it. I can't rearrange them. If that's possible, if that's what we have to deal with, and again, we don't get to answer that question. That is inherent in the problem or given by the person presenting the problem. If no, then what we get is called a combination. And we will be counting combinations. And here's how we do it mathematically, then I'll show it to you on a calculator. To do it mathematically, we do the same thing we did for the permutation. We take 8 times 7 times 6, exact same thing, but then we have to divide by a factorial. We divide by the factorial of how many trials there are. In this case, since there are 3 trials, we're going to be dividing by 3 factorial. So this problem becomes, we know this is 336, and we know 3 factorials, 3 times 2 times 1, which is 6. So this problem becomes 336 divided by 6, so that's 336 on my calculator divided by 6, and it says that's answer of 56. I claim that there are 56 combinations when you choose 3 letters from 8. And we have 2 stipulations here. Once I've used a letter, I can't use it again. And once I've made a selection of 3, I'm not allowed to rearrange those. We're saying here that the order is not important. Changing the order does not constitute something else we're going to count. Does not constitute a new arrangement. Let me show you on the calculator. As you might guess, once again, under NPR, or under the PRB key, there is the function which is called NCR. And of course, the C stands for a combination. So the way we would do this one is we press 8. We have 8 to choose from. Press the PRB key, but now we use the right arrow key so that the underscore is under the NCR function. And then we just press a 3. And what shows up on the screen is 8 NCR3. The number of combinations you can have is 56. So this concludes my presentation of combinations, permutations, and how we use the fundamental law of counting.